Hi, everybody. This is 5.6. It's linear programming. It's the last section. It's probably one of my favorites. It will probably be your worst favorite. What you do here, it's all story problems. And you got to pull out the lines from the story problems, like what they want you to graph it, and then figure out where it makes sense. It's awesome. I hope you enjoy it. Okay, so we're going to write what we call an objective function. An objective function is what we're trying to maximize or minimize. We do not graph this, so this one here is not graphed, all right? And then we're going to find our inequalities, our limitations. These are just different lines that actually meet our situation. We're going to graph these, and then we're going to use linear programming to solve. In other words, we're going to plug in their intersections or their vertices into our not graphed equation, our objective function, to see where it makes the most sense. This is called linear programming. All right, so let's just start with writing some of these objective sentences. Okay, an algebraic expression, two or more variables, maximize or minimize. So here, a company manufactures bookshelves and desks for the computer. So I know I have bookshelves and desks. So my bookshelves and I have desks. Let X represent the bookshelves. Okay, this is important because this helps us graph. So we all do it the same. All right, and Y is for our desks. Technically, you could do it either way. It wouldn't matter. Okay, the company profits are $25 for the bookshelf. So I make $25 on this guy and $55 on the desk. Write an objective function. So I want to maximize my profit. And profit is Z because we do not graph this one. So Z is, it's 25 for every bookshelf. So 25 times X from here and 55 times Y for the desks. Okay, that's our objective. It will not get graphed. It's what I want to maximize or minimize. This case maximize because I always like the most profit. Okay, the company should not manufacture more than 80 bookshelves and desks. Generally, this would all be one paragraph where we're breaking it apart. So that means more than, so it has to be less than. That's what that means. Bookshelves and desks means I'm going to add them together. So the bookshelves plus the desk have to be less than or 80 total. One equation. Then it says the customer's needs must be met between 30 and 80 bookshelves and between 10 and 30 desks. So X is between 30 and 80. Y is between 10 and 30. Actually four more lines there technically. All right. Now we want to graph these. So this is what I want to maximize. I am not going to graph it. These are the lines I was given in my reading. So now we have to graph all those. So X plus Y equals 80. That one's actually very easy as intercepts because if X is 0, Y is 80. And if Y is 0, X is 80. All right, less than or equal to. So we're going to draw a line that's solid. Please use a straight edge because where they intersect is very important. So you should be using a straight edge to graph these. Even though I do not have one, you must do better than me. Why is this not drawing? Come on. All right, so that there. I'm going to plug in 0, 0. Well, this time I know I can't have negative amounts, so everything's in the quadrant 1. So when I plug in 0, 0 to my X plus 80 is 0 plus 0 less than 80, the answer is true. So this guy shades this way. All right, I'm going to use a new color. So now we have to do the next one, and it says X is between 30 and 80. So it's greater than 30 if we read this way and less than 80 if we read this way. Remember X line, so X equals 30 is straight up and down. It's right here. And X equals 80 is here. We've got to figure out how to calibrate these. It's in between, so greater than 30 means it goes this way. Less than 80 means it goes this way. So it's everybody in between. So currently, I have this part right here double shaded. But now Y also has stipulations. It says y is between 10 and 30. So y goes this direction. So I've got my y line here between 10 and 30. And my y line here. Okay, and it's between, so it's shading here. So where everything is shaded, so where do I have blue, red, and green? That's this area right here. All right, my intersection points are here. So 30, 10, 30, 30, 60, 30, and, oh, this was graphed wrong. I missed completely. All right, let's redo this. Where's my, all right, that's wrong. This blue line is off. So I'm hoping yours was better. Okay, now the blue line has to be exact because where these intersect is very important. There, that's better. All right, so we're going to get 50, where are we at? 50, 30 for one line and 70, 10 for the other. All right, I'm going to use those vertices to maximize or minimize my function. So now we're going to plug them in to this equation. So down here, I've made a table for you just to help you out. So the points we're going to plug in are our vertices. So we're going to plug in the 30, 10. We're going to plug in the 30, 30, the 70, 10, and the 50, 30. That's what we had up there. All right, you're plugging into this equation. So you're really just doing 25 times 30, whoops, plus 55 times 10. Plug it in your calculator and you should get 1,300. And you do this for all of this. 25 times 30 again, plus 55 times 30, and you should have gotten 2,400. And then 70 times 30, plus 55 times 10, and you should get at 2,300, very close right here. And then you should have taken the 50 times 30 plus the 30 times, 55 times 30. I wrote that really bad. 55 times 30, and you would have gotten 2,900. All right, so this is my maximum profit. This is what I want to make. And this is my minimum. This is the minimum I will make when I create these bookshelves and desks. Okay, that is how you do a story poem. Yours is much longer. All right, I would like you to pause and give it a shot and see how you do. Okay, and when I hope you're ready, you should have read you had water and you had medical kits. Okay, what do we know about the water and the medical kits? We know water will help 6 people. We know water will help 10 people. There we go. And medical kits will help 6 people. I am going to let X as the number of water. So this here is X, and my medical kits is Y from my reading. Okay, I know that water is 20 pounds, and I know that medical kits is 10 pounds, and I know I have a total of 80,000 pounds. That's a total that I got. I know I have 1 cubic foot for water and 1 cubic foot for medical kits, and I have a total of 6,000 cubic foot on my plane. So now we got to write an equation. So now we match things. So I know this is 80,000 pounds. So this is pounds, and these are pounds. So this has to go together. So 20x plus 10y has to be less than or equal to 80,000 because I can't have more than 80,000 pounds or the plane won't fly, right? Okay, now cubic feet, it's one of each, so 1x plus 1y. And I know that has to be less than or equal to 6,000 because that's all the more room I have on my plane. I am trying to maximize the number of people. I hope you got that. So how many people can I help? Well, I know it's 10x plus 6y. And this is like my z function. This is what I want to maximize. How many people I can help. So now we got to graph all these. So when we do this, if we do the xy again, I'm going to multiply by 100 here. X and y. So x plus y at 6,000 is pretty easy because that means they're both at 6,000. When x is 0, y is 6,000. When y is 0, x is 6,000. So we're going to draw that line in. Use your straight edge again. Make sure you're doing well. Come on. Seriously, line. All right. When we plug in 0, 0, is 0 less than 6,000? The answer is yes. So this is shaded this direction. Okay, now we need to graph our other line. This time it's probably easier to solve for y. So let's go up here and do that. Skype blew my y went away up here. Okay, so I'm going to solve for y here. So the first thing I'm going to do is subtract 20x. I'm going to work over here. So 10y less than or equal to a negative 20x plus 80,000. I'm going to divide by 10. So y is less than or equal to a negative 2x plus 8,000. So my y-intercept is 8, 80, and I'm going to go down 2, or I can go down 20 over 10, or, oops, so let's go up here. Oh, for real. I can go down 200 over 100, so go down 2 over 1. Oh, I need a different color here, so we can see what we're doing. Again, it's less than or equal to, go down 2 over 1. All right, this is really jumpy today. 2 over 1 and 2 over 1. So let's draw in our line. Again, when we plug in 0, 0, it's true, so it shades this way. Now the parts that are double shading are kind of tricky here. When you look here, it goes from the 60 to the 40 or 2040 down to the 40, and then we know it has to be first quadrant because I can't have negative number of people, our waters and bottles. So now we have to maximize my 10x plus 6y, our people. Our points we're going to have are 0, 60. We have this point right here, which is 2040. We have this point right here, which is 40, 0. And technically, we also have 0, 0. But we know that's going to help no people. Plug this in, so we got nothing here. So we plug in 0 for my x plus 60 for my y, and we get 360. Now let's plug in 20 for my x plus 40 for my y, and we get 440. Plug in 40 for my x and 0 for my y, and we get 400. Now when we look at this here, that means the maximum number of people I can help is 400, and the min, of course, is 0. All right, I hope you did a good job. Good luck on your homework, and then we're on to review.